Good day, everyone. Welcome to the second lecture of this class. The title of the presentation is Research Methodology. I am Dr. Nico Lawrence Dosin. I'll be the course instructor of this class. Here is the lesson objectives of this session. At the end of this lecture, the student should be able to identify the most suited research design for the study as prescribed by previous studies, establish the protocol in designing and developing the materials needed for the research study. Number 3, identify the research locale, research participant, something that needs to be used. Number 4, locate, design, and develop research instruments. And number 5, discuss in detail the research procedure and the ethical consideration of their study. Let's define first what is research design. Research design is a framework or blueprint for conducting a research project. It details the procedures necessary for obtaining the information needed to structure or solve the research problems. In this presentation, you will be encountering the three most usable research designs, which include the descriptive research design, experimental research design, and correlational research design. So in conducting research, you will be encountering different kinds of data. It could be a qualitative data or quantitative data. When we say qualitative data, it is composed of descriptive words that depict qualities and characteristics. While you have quantitative data, you are dealing with numbers or numerical data, wherein it depicts numbers, counts, and frequencies. If you will combine the qualitative and quantitative data, you will be using mixed methods research design. And the three most common mixed methods research design include 1. Convergent parallel mixed method research design. 2. Explanatory sequential mixed methods research design. And number 3, exploratory sequential mixed method research design. For the first type, you have the convergent parallel. You are doing simultaneously the collection of qualitative and quantitative data. For explanatory sequential mixed method research design, you are dealing first with quantitative data and then qualitative. For exploratory sequential mixed method research design, you are dealing first with qualitative data and then you proceed to quantitative data analysis. In the given table, it shows the summary of the difference between qualitative and quantitative research execution. For qualitative research, somehow in terms of small sizes, small sample sizes rather, for qualitative, small, for quantitative, large. So qualitative, typically less than 20, while for quantitative, typically beyond or equal to 100 respondents. I'd like you to take note of the differences of the word. For qualitative, we are using the word participants, while for quantitative, we are using the word respondents. Data collection methods, we could have one. For qualitative, we could have 1:1 interviews, observational research, or focus group discussion. In quantitative, we could have surveys or online survey using online web capture. Data types for quantitative, more on behavioral patterns, natural language. While for quantitative, you have numerical values. How data is analyzed in qualitative research. You could have identifying patterns in participant behaviors and responses, While in quantitative, you can use numerical methods and statistical analysis. How data is presented in qualitative research, you could have original quotes or videos, while for quantitative, you can present the data through tables, charts, and graphs. Another table that differentiates quantitative and qualitative research. For quantitative, it is somehow objective, while qualitative more on subjective. Maybe because of the nature of data that we are dealing with. Types of reasoning, quantitative, more on deductive reasoning, used to synthesize data, while qualitative research, more on inductive, you are starting with small group until you generate or synthesize the data. While for quantitative, it's somehow concise and narrow, while qualitative, you have complex or broad. In terms of applications, quantitative tests theory, while qualitative develops theory. In terms of basis of knowing for quantitative, you have here cause and effect relationships, while qualitative, meaning, discovery, and sometimes correlation. For quantitative research in terms of basic element of analysis, numbers and statistical analysis, while for qualitative, you could use words, narratives, and sometimes you're using themes. That's why you are conducting thematic analysis. For scope, for quantitative, single reality that can be measured and generalized, while qualitative, multiple realities that are continually changing with individual interpretation. Maybe because you are focusing more on the experiences of your uh, participants. Okay, let's now proceed to the first type of research design, which is descriptive research design. For prescriptive research design, it is a theory-based design wherein the researcher is primarily interested in describing the topic. Take a look at the keyword, describing the topic that is a subject of the research. It is applied in case studies, naturalistic observations, and surveys. There is a modifier, a naturalistic observations, because you are just documenting which are the data that can be perceived only by the five senses. This method includes data collection, analysis, and presentation. It lets the researcher clearly present the problem statement in order to allow others to understand the need for this kind of research. Basically, descriptive research design serves as the foundation of different or various researchers. Second one, you have correlational research design. It allows the researcher to establish relation or relationship between two closely related topics or variables. It is not experimental research. Research design that requires at least two groups of data, at least two groups. It can be applied to case control studies and observational studies. I'd like to clarify at this point the difference between correlation and causation. When you say correlation, you are just determining the relationship between the two variables that you are studying. You are not, for example, you have X and Y. You are not, you're just correlating or finding the relationship that exists between X and Y. You are not saying that X predicts Y, because that is another design, which can be attributed to the next design, which is the experimental research design. If X determines Y, it's no longer correlation. It's more on causation because one variable causes the other variable to change. That's not correlation. That is causation. Again, correlation, you're just describing the relationship that exists between two variables. In the given example here, you can see here how x related to y. So it's a strong positive correlation. As x increases, y also increases. In the second illustration, you can see here that while x is increasing, y is decreasing. That's why there is negative correlation. Well, this one, you cannot see here any linear correlation because the scores are somehow spread out or somehow scattered. That's why there is weak positive correlation. Third one, experimental research design. It establishes relation between cause and the effect. It's more on the causation of particular variables. Here, the researcher observes the influence of an independent variable on the dependent one. So in some other books, independent variables are termed as cause, while dependent one termed as effect. For instance, you can observe the impact of the price, for example, price, the independent variable on customer satisfaction. So in the given example, it's more on the business example. If you increase the price, what would be the behavior or the customer satisfaction of the customer? So the change of the price, there will be an effect of that in the customer satisfaction. Usually, this type of research design contributes to solving a particular problem by manipulating the independent variables to observe the change they have on the dependent one. Okay. Another example in the field of education. So, for example, if we change the student engagement, will that uh, will that reduce somehow change on their academic performance? So you are trying to relate the change of cost in uh in terms of its effect, which is the dependent variable. Okay, this illustration shows you the different setup that you can do when you have your research. There is one, two, three, four, five, six setup. Each setup it has three replicates. We are doing replicates so that we will be able to verify uh, if one replicate represents the other. So this classical example is applicable if you are doing biological research. If you want to compare the effect of one treatment to another. In the given example, having negative control, 25%, 50%, 75%, 100%, positive control. Example, you are trying to test a particular effect of the pesticide. For example, your negative control is your water. Your positive control is the commercially available pesticide. The 25% is the combination of your product plus the commercial 25% diluted, 50% diluted, 75%, and 100% pure substance. Okay, so you can compare that and you can verify the results using the results that might be produced by replicates. Okay, under experimental research design, specifically if you are conducting uh, scientific research. So these are the following experimental research designs. 2, 4, 6, 8. There are 8 research designs under experimental research design. We'll discuss them one by one. Let's start first with one group with only post-test design. So the X stands for treatment, while O stands for the outcome or the result. So in this example, the subject is exposed to a treatment, which is an experimental factor, and then post-test is given. So if it, mean to say there is no administering of, or there's no administration of pre-test. So in one group with only a post-test design, there is no pre-test. You just immediately introduce the treatment and then identify the effect using the post-test. So in education, you can do that treatment and then observation. So pre-test is neglected in this design. So it is biased because all changes are attributed to the experimental variable. Nawalan ka ng initial basis. So you lost the initial basis. Second one, this is an example, another example of process design. It is done in mice. So the vaccine that is integrated to the mice or any molecule incorporated to the mouse of the to the body of the mouse rather. So we just impose the treatment and then identify the outcome. Second one group with a pre-test and post-test design. So the O, you observe it using the pre-test, you provide the treatment, and then you also provide the post-test as the outcome. So OXO is one group with a pre-test and post-test design. So the subject is given the pre-test before the start of the experiment, and after the treatment, the post-test is given. So this kind of setup limits the bias of the experiment. Most of the research design that they are using, specifically if you are conducting some experimental research design in education, this is the most common research design. So another example, third group, you have Solomon for group design. I'd like you to look closely at the figure. There are two experimental groups and there are two control groups. So the group one of the experimental and control group both receive a pre-test, while experimental group 2 and control group 2 did not receive or did not answer the pre-test. Okay. Experimental group 1 received the treatment, so as the experiment group 2, because they are experimental group. So the only difference between the experimental 1 and experimental group 2, the experimental 1 has pre-test while the other doesn't have. And then post-tests are given to them. So control, pre-test, post-test, control group 2, there is no pre-test, just post-test. So it's how you will get the result. You can compare this one, the result of A and B or experimental and control. So you will check if they are or if they are behaving in the same level at the beginning of the treatment. And then the second line, the difference between the pre-test and the post-test with the treatment for A, this one. So here, identify the effect of the pre-test, treatment, post-test. On the other hand, pre-test and post-test, no attribution of the treatment. On the second one, you can see here the no pre-test, treatment, post-test, and then this one post-test only. So by taking look at the arrow, which arrows which are being computed, which are being related. So for example, the B and the D, the pre-test of the control group and the poses of the control group 2. This one, comparing poses of this group. The second one, the poses of this all, and then the poses of control group 1 up to the control group number 2. Next, randomize multi-group with a poses design. So in this example, there are different replicates. Replicate 1 to 3 per type of fertilizer, and then they identify the most effective outcome. So in the given example, by getting the mean score of R1, R2, R3, we'll be able to identify which of the three sets of fertilizer has more impact to the plant. Okay, to continue, the next research design is randomized multi-group pretest and post-test research design. So the difference between the previous research design, in this research design, there is no given pretest. However, there are three simultaneous groups, three replicates that have different sets of data. So if you're going to examine different design, there are several statistical tools that can be utilized in each research design. If there are two groups, there are three groups, there are specific statistical tool that you can use to analyze your data. But at this point, I'd like to introduce only the research designs. Here, the difference, it has pre-tests, and yet there are three sets of data with three replicates each set. Next one, you have the match group. For the match group, for example, this is the experimental group and control group. So, for example, the A1 is section 1, A2 is section 2, A3 is section 3. So you can divide the A1 or the group A or the A1 into control group. For example, in section 1, if there are 50 students, and you can divide the class into A1 which will be classified as experimental group, and the second one which will be classified as control group. So you can split the class into two different groups, which you will call them as match groups. The next one is factorial design. So the difference between factorial design, you have the pre-test, treatment 1, treatment 2, and then post-test. So at this point, we are introducing two sets of treatment. It could be the first factor that you are investigating. It could be the type of fertilizer that you are using. Second one, the species of plant where you apply these fertilizers. Okay, so in the field of education, it could be the first set would be the type of teaching strategy that you would like to employ or you would like to infuse in your classroom teaching. And the second one, it could be the learning modality. It could be in-person classes or it could be online classes. So if you are studying that kind of uh, research study, wherein you are conducting, wherein you are investigating the effect of learning modality and teaching strategy at the same time, you can use factorial research design. And crossover research design, they have the same pre-test and post-test. However, the sequence of the treatments is altered. The sequence of the treatments is altered. So in the first group, you could have here treatment 1, treatment 2, treatment 3. For the second group, treatment 2, treatment 1, treatment 3. For the third group, treatment 2, treatment 3, treatment 2, treatment 1. Okay, so for example, in the field of education, you are trying to test three teaching strategies. First, for example, you have game-based learning. Second, you have gamification. Third, you have a collaborative learning. So you are conducting these three uh, teaching strategies. However, the manner or the sequence of the implementation of different teaching strategies are what I call this are randomly distributed, but as long as within the period of the implementation. So for example, in the week one, group one will experience strategy number one. Group two will experience teaching strategy number two. Group three will experience teaching strategy number three. And then for the second week, the group two will experience teaching strategy number two. Group two will experience teaching strategy number one. Group three will experience teaching strategy number two. Same as week three, group one will experience teaching strategy number three. Group two will experience teaching strategy number three, while group three will experience teaching strategy number one. Okay, so you can see they have the same pre-test and post-test. The only difference among this group, you can see how the treatments are alternatingly uh, exchanged throughout the implementation. The logic behind this crossover experimental research design is to test if the sequence affect the post-test or no, or it is trying to prove if the sequence does not affect the outcome or the other way around if the sequence affect the outcome. Okay, so one of the characteristics of uh, quantitative research design is to compare the or to test the theory. So it's more the theory of order. Okay. Another research design that I'd like to share to everybody is the counterbalance experimental research design. So take a look at this figure. There is group one and group two. The study is lifted from the taxo card game in promoting concept retention in mastering animal classification. This is published in American Journal of Innovation in Science and Engineering. Okay. One of the issues in experimental research design is the presence of bias. Diba? The researcher might have bias on the treatment that he or she is trying to implement in classroom. So to counter or to think of another research design that will avoid the bias, you can use this design. Okay. At the beginning of the experimentation or conduct of the study, there is pre-test, the T0. Okay. In the session 1 to 3, group 1 utilize the taxo card or the card game, while the group number 2 just only use worksheets. After the treatment, T1 or test number 1 is given. Session 4 to 6, it is now become alternating. Session 4 to 6 for group 1 worksheets, for group 2 with taxo card. And then T2 is given at test number 2. And then after within session 7 to 8, group 1 again uses the taxo card, while the group 2 uses worksheets. Then on session 9 to 10, worksheets for group 1, group 2 with taxo card. So the logic behind counterbalance experimental research design, number 1 is to avoid bias. Number 2, since it's a counterbalance alternating implementation of the intervention, you can say that the first phase just tests the effectiveness, while the second phase or the later part of the experiment, you can see the reliability of the scores. Okay, so if you get the uh, consistency of the scores, if the tax card didn't really improve the concept retention, so you could have a valid proof because you implement the intervention twice, the experiment. Okay? So based on the result of this study, it says that there is no difference between taxocard and worksheets. So we can infer that it's still effective based on the result. However, we can conclude that taxocard is also as effective as worksheets. So we can infer that it can serve as alternative instructional material. Now, how do you write your research design? First, you need to identify the most appropriate research design to be used. So you mentioned that in your paragraph. Second one, discuss the feature of your research design. If you'll be using correlational, what kind of variable are you going to relate or get the relationship? So you discuss that. And also, cite a literature or study that justifies why your chosen research design is the most suited or most appropriate for the study. So it's not just mentioning it's my research design and these are the features. You also need to validate your chosen research design using a literature or study that justifies why is that the best research design for your study. So once I check your paper, I need to see these three components. Identify the most appropriate design, discuss its features, and third one, justify with literature why it is the best. That's why the term research, diba? Something that you need to search again. Okay? So the next phase is material development. This section contains a discussion on the design and development of the instructional materials that will be utilized in the study. Sometimes it's included in the research instrument section, but in most of the strategic intervention material papers, material development is somehow separated from the research instrument because this phase narrates how the material or instructional materials was designed or developed. Okay. In the given illustration, you can see here the material development protocol adapted from Gutierrez 2014. So it has three major stages: preparatory stage, game development stage, revision stage, and pilot testing. This is the example of the Taxo card game developed in the study I mentioned earlier. So it is advisable to include some photos of materials in order to illustrate simply the developed materials. For readers and editors, it is a plus point when they see the appearance of the material because they will see that you really conduct the study, you have the evidence of the material developed, diba? It's not just you hypothetically design by yourself. So if there is a proof that you can provide for this section, better. Now, the next topic will be about research instruments, but let's recall the essential part of research. Your SOP or statement of the problem should be aligned with your research instrument. And each SOP should be accompanied with proper data analysis or data analysis protocol or procedure. So if you fail to identify what research instrument to use or to be used, it will be hard for you to answer your statement of the problem. So it's just like finding proper ruler or measurement tool to measure the constructs or variable that you would like to measure. To continue, now let's define what is research instrument. These are measurement tools, for example, questionnaires and scales designed to obtain data on a topic of interest from research subjects. A measurement tool designed to obtain data. It is a tool to collect, measure, and analyze data related to your research interest. Okay. Let's have a clear vocabulary first of research instrument. So research instrument can be a measurement tool, can be an assessment tool, or evaluation tool. But these three words are not the same. They are related words only. So for example, if you want to quantify the attributes or quantify your variable, you call your instrument as measurement tool. While if you want to collect quantitative and qualitative data, you call your research instrument as assessment tool. But if your research instrument aims you to analyze quantitative and qualitative data, it is termed as evaluation tool. Okay, so again, they are not the same tools, but they are interrelated tools. Measurement to quantify the attributes, assessment tool, collect quantitative and qualitative data, evaluation tool, analyze quantitative and qualitative data. Okay, so for example, the given topic is improving students' conceptual understanding, collaborative skills, and engagement in Mendelian genetics using digital courseware. So these are the problems among how can the students be described in terms of their conceptual understanding, collaborative skills, and engagement. Number two, is there a significant relationship among the above mentioned variables? So this time we'll be using concept tests for conceptual understanding and survey, questionnaire, or classroom observation tools for collaborative skills and engagement. As you can see, survey questionnaire is not the only instrument used by the researcher. It also required uh, classroom observation tool. Probably because the researcher would like to confirm if the students really collaborate or engage. So the quantitative and qualitative data would justify or would prove if collaborative skills and engagement are really demonstrated by the students. Again, if you are measuring constructs that are skill-based or attitude-based, survey is not enough because survey is somehow biased. So in order to validate your results, you need to provide more evidence such as observation. So you can create classroom observation tools. Yeah, a reminder, if you are measuring skills or attitude, it has to be demonstrated. It has to be performed by the students. So classroom observation tools are necessary. Again, if you are using qualitative research instrument, you will generate more of words, while quantitative, you will generate more numbers. Example of quantitative research instrument, demographic profile for a survey questionnaire, dichotomous item, for example, if you're answering male or female question, uh, checklist, rating scales, semantic differential scale. Demographic profile, example, gender, age, education, and marital status. This is the categories, and these are the responses. The next instrument is dichotomous key. So it could be yes or no, male or female, married or not married, correct or incorrect. You can also have checklists. So the difference between checklist and a rating scale, in checklist, you're just checking if there is a presence or absence of the observed variable. If it's not present, X. If it is present, check. While rating scale, you can see here some ordinal scores. Like for example, very good, good, okay, poor, very poor. So there is ordinal data that you can get through rating scale. Another example of a rating scale, evaluating the student's ability. So from exceptional to poor. So 6 for exceptional, 5 for superior, 4 for above average, 3 for average, 2 for fair, and 1 for poor. So in terms of if you want to quantify the student's performance like skills, you have to use rubrics. And rubrics are composed of three major parts: the criteria that you would like to observe. Second one is the performance rating. Is it excellent, good, satisfactory, or needs improvement? While the cross-section between performance rating and criteria, you can see the performance description. Okay, to continue, what about a qualitative research instrument? You can use observation and you could use interview. Through observation, it could be a direct observation or it could be a structured observation. While for interview, you could have a face-to-face or in-person or online interview. It could be an in-depth versus semi-structured interview. It could be a discussion group or focus group discussion. So if you will use observation, I suggest you use classroom observation tools. While for interview questionnaire. This is an example of classroom observation tool from the Department of Education. This is a sample of interview questionnaire. Student journal. You can also use it as your evidence in your study. Learning logs in other book. You can investigate their levels of thinking. What are the difficult subject topic that they find it hard to learn? Or what are the topics that they think they need to master more? Or what are the topics that's easy for them to understand? So, student journal. And in terms of analyzing the qualitative results, you can use thematic analysis by generating the data that you have. You do coding, and then after coding, you are assigned coding. These are the repetitive words that you can encounter through their responses. And then when you assign code, you compare them repeatedly. So you have iterative comparison. Until such time, after the coding, you will be able to establish the themes. Okay, I will be sending another video that will contain how to do qualitative analysis or thematic analysis from qualitative data until you develop the themes. So for example, this is a transcript of your interviewee. You see some repetitive words, so you assign them as code. And those code, once you combine them from responses of different respondents or participants, you will be able to establish themes. Now, where to get your research instrument? Of course, first, from the review of related literature and studies. That is why it's very important for us to read more before we write. Because as we read more, we will be able to explore other source of data or source of information where we can obtain the type of questionnaire that previous researchers have utilized during their previous studies. Second one, you can search through online resources, through internet, publish full paper, online research repository. Now, what are the psychometric properties that a research instrument should possess? Number one, validity, or the purposes or intention of the measurement tools. The purpose, the objective of the research instrument, why you utilize them. So there are four at least characters or properties that these instruments should possess. First, face validity. When we say face validity, it is the appearance of the research instrument. Content validity, it refers to the uh, component, component and technical properties of the instrument. Okay, are they aligned with the objective of the study or the statement of the problem? So that is the content validity. Now, in terms of construct validity, you are now trying to compare the instrument in terms of the interaction of the particular construct or variable with other variables. Or this time you are investigating if the research instrument is aligned with the conceptual framework of the study. So that's the construct. You're trying to figure out the interaction among constructs or variables. Number four, predictive validity. So this time you are trying to investigate if the instrument that you will use will predict somehow future performance. Okay, so for example, the achievement test that you have acquired or you have adopted from your reference, there is a predictive validity indicated there. Okay. And the last one, you have the reliability or internal consistency or stability of the measurement tools through time. Now, how to write your research instrument in your research paper. So if your research instrument has one section of test item, you mention the name of the instrument, you identify the number of items, and identify the purpose of the instrument in attaining the goal or goals of the study. Example, concept test. Is the name, how many items, and what is this for? So concept test, period, italicized and bold. It is a 20-item researcher-made test which aims to measure conceptual understanding of the students in Mendelian genetics. What if your research instrument has more than one sections of the items? The technique here is uh, state the name of the instrument, the main purpose of the instrument, the generic instrument, and the purpose of that in attaining the goal of your study. And then discuss each section. Section one, and then how many items, and what is that for? Section one, section one, the first one is demographic profile. A demographic profile, it has 10, demographic profile has 10 questions which aims to describe the age, socioeconomic status, sex, income of the respondent, something like that. Okay, so that's the flow. name of the instrument, main purpose of the instrument, section of the instrument, number of items per section, and its purpose or purposes in attaining the goals of the study. Okay, so this is how you write your research instrument in the paper. Now, in selecting instrument, there are two words that we want to be mindful of. The first one is adopt with the O and adapt with the A. So what is the difference between the two? Adopt, there is a complete acquisition and utilization of the developed instrument. You just get it in total. Whatever it is, you adopt. So complete acquisition and utilization of the developed instrument. While the term adapt, there is modifications on instruments prior to utilization of the developed instrument. It could be you add some sections, you add some number of items, or even you reduce. It's also adapt and rewording. However, if you adapt with a adapt research instrument, it needs to undergo revalidation with content expert to see if the items can still answer your research question or still align with the conceptual framework. Okay? So when do we need to stop selecting the right research instrument? So for example, you just want to adopt the letter O. Adopt ka lang, then utilize. Adopt and utilize. So when do we stop selecting? Number one, when the objectives of the study can no longer be met by the existing instrument. For example, the one that you have searched is already 10 years ago, and there are new constructs that we would like to develop. Example, in the use of technology. 10 years ago, the kind of signals that we have is not the same as what we have right now. So if in terms of technology, it could not be the same anymore. So you need to stop selecting. Another example, if you have uh, advancement in the medicine. So for example, 10 years ago, there's no COVID-19 yet. So if you have instruments that talks about COVID-19, it can no longer be answered anymore. When the topic is novel in the field of specialization, technology, infectious disease, recent advancement, so you stop adapting na. You need to create your own instrument. When the context of the existing instrument is so far already to the respondent and participant. Example, the instrument that you have searched is from the Western countries. So you cannot adopt it anymore. You need to contextualize. You can adapt with letter A and do revalidation, but no more complete acquisition. Thus, developing new instrument is highly encouraged. Validation of the research instrument. So you can ask content expert valid. You need to undergo content expert validation process. Expert of the subject matter, specialists in the related topics, at least 3 content expert, at least 3. Preferably a 3, so if there are ties or if there is a tie between the decision, there is a middle one that will decide. So 3, the next with 3, 5, 7. It's always odd number. So if there are tie or if there is a tie score, there's a tiebreaker. So this is the original organizing the result of the instrument. So for example, you have this is the original responses of your research of your validator rather. But the format of the instrument is proper. Naglagay siya ng 4. Oh. He plays 4 here. Okay? He plays 4 here. Therefore, when you process them, the answer of validator number one, 4. So you put it here, 4. Example, your validator number 2, it shows 3.5, the mean score here. For example, uh, 4, 4, 4, 3, 3, and the mean score become 3.5. So you just put it 3.5, 3.75 for validator 3. You get the mean. Therefore, the format of the instrument is proper, highly acceptable. Okay? The first one is the original, and the second one once you process their responses. Now, in data collection technique, these are the following methods and the consideration that you need to consider. For survey, selection of responses. How many responses are required for the research? Survey distribution, will it be online, by post, or in person? Techniques to design the question. For interview, criteria to select the interviewee, time and location of the interview, types of interview, will it be structured, semi-structured, or unstructured? For experiment, place of the experiment could be in the laboratory or in the field. For experiment, measurement of the variables, design of the experiment. For secondary data, criteria to select the references and source of data, reliability of the references, and techniques used for compiling the data source. Now, we're done with the preview, with the basic parts of the chapter 3 or the research methodology. Now, this time, how to write your research procedure. Number 1, you have to state the steps logically and in detail as you follow a particular research protocol or a model. This is to ensure that the readers can replicate your study once they follow your protocols. We all know that the research that you will be producing can be replicated in the near future with different contexts. They might change your sample, your location. So in order for them to easily grasp the content of your paper, it is important that you state them in detail. Because once your paper is published or presented elsewhere, you are not with them anymore. It can be read anywhere, specifically when they are published. When they are available through internet, you are not with them to explain to future researchers what you did. So all you need to do in order for them to easily grasp your content or your procedures, you must state them in order. Now, in some theses or dissertations, illustrations are provided in the form of flowcharts because there are a lot of spaces. Unless if you are publishing a research paper online or in some journals, limited. There are very limited uh, sources or pages that can be allotted for your paper. So sometimes they disregard that flowchart. Instead, your words only are being considered. And also in the research protocol or research procedure, you must also cite your ethical conduct of the study. The briefing process of the respondents must be observed before the intervention. And after the intervention, they must be debriefed. They must be informed about their scores, their performance throughout the experiment. So you must secure consent form at the beginning of the research procedure. The research procedure will start as soon as you collect data. As soon as you collect data. In the case of your paper, the collection of data in the scene or the strategic intervention material is discussed in the material development section. But this time, as you generate data, that's the start of the research procedure. Okay? Now, there is a separate discussion for statistical treatment, which I will be giving you in separate video. But at this point, I'd like you to see only the relationship of statistical treatment to SOP. So for example, you have this kind of descriptive questions. The statistical test that you can use is mean score, percentage, difference. If you have inferential question like this one asking for relationship, you can use Welch, uh, it's a relationship, test of difference rather. You can use analysis of variance, or which we know as F-test, or you can also use its another version, which is Welch F-test. F-test is used if you have three or more data, or two or more data. Like t-test is more versatile as compared to t-test, but it observes at least two properties. There must be homogeneity of variance, and your scores are normally distributed. So if your scores are not normally distributed, rather skewed, you have to use Welch F-test. Okay? So the assumptions of ANOVA or F-test, if the assumption of Welch of F-test or ANOVA is not met or are not met, you have to use its another variant, which is Welch F-test. Okay? Number 3, for tests of relationship, you can use Pearson R. Okay? Because these are scores, these are interval data, they can use Pearson R. With that, that's all for the research methodology. I hope you learned something. I am Dr. Nico Lawrence Mendoza, the course instructor of this section. With that, goodbye everyone.